Alright guys, I want you to know that I'm feeling kind of silly because I made the whole A video and then I accidentally deleted it before I uploaded. So you'll notice on my notes, they're already a little filled out. I'm just going to talk through them kind of slow. So 4 goals. This one, understanding polynomial multiplication. Then B will be on factorizing polynomials. C will be on common products. I'm going to call that tips and tricks. And then D is on rational expressions and how we add, subtract, multiply, and divide those. On your notes here, we have this kind of cheat sheet here of common things you might want to be finding yourself familiar with to make your life easier. Okay, so on my notes, I'm going to try to cover them a little. So what do we know about multiplication already? We know that when we multiply, we take some value times another value, and we can view any multiplication as a form of area, right? So 15 times 10 can be looked at as 10 plus 5 times 5 plus 5, giving us 50, 50, 25, and 25. So you can talk about area in terms of the sum of the data, 150, but you can also talk about area in terms of length times width, 10 times 15. So that's kind of a way I like to think about multiplication of polynomials, that you can think about it as length times width or as the sum of the area. Okay. So this one right here, given this, how do I multiply it together? Well, I like to use binomial times a binomial, multiplying each of the boxes together, and then summing up our common terms to give us our center value. Okay. This one is a polynomial, more terms, times a polynomial. Work this out, 6x to the 5th, 9x to the 4th, negative 6x to the 3rd, 3x cubed y, 4x squared, 6x cubed, negative 4x squared, 2x squared y, and then 14x cubed here, and if you want you can fill this the rest of the way out. But what I wanted you to see here was that that common term thing happens all the way down here. We've got kind of something weird because we threw in an extra variable, so our lives get a little bit messy here. But this common term thing can be a great strategy for answering complex questions. So I want to use this idea to help me answer this question. I've got 4x cubed plus 2x squared minus 7x plus 2 times the quantity 9x to the 7th plus 2x to the 6th plus 3x to the 5th plus 4x to the 4th. And it doesn't want to know what the entire answer is. It just wants to know what are the 3 terms, the first 3 terms, written in descending, so from the biggest power of x down in order of x. So the way that I looked at this was I went ahead and used my polynomial to help me keep my idea organized, and I wrote descending order of x this way, descending order of x this way, so that when I got my products here, I knew that my products would be also in terms of descending order of x. So 36x to the 10th, 8x to the 9th, 12x to the 8th, 18x to the 9th, 4x to the 8th, and negative 63x to the 8th. Well, my first 3 terms will be the one that has the x to the 10th, then x to the 9th, then x to the 8th. So I can simply sum up my diagonals here to come up with my first 3 terms. So 36x to the 10th, 8 and 18 give us 26, 12, 4, and negative 63 is going to give us negative 47x to the 8th. So this is just sort of a shortcut you can do when you think about what all of these are to help you answer this question. So if it wanted to know what would be the coefficient of the x to the 6th term, you could build this table out and then look for where your 6 would be. These would be the 7s here, and your 6 would be along this line. So you could just figure out that and go from there.